Greetings humans, Ryan Lemon here, talking to you about maths. We're going to be talking about x and y intercepts, and they're fun to discuss. So an x-intercept is simply where the graph, or a graph, crosses the x-axis. All x-intercepts have the form x, 0. All y-intercepts have the form, you guessed it, 0, y, where y is some number and x is some number. So what does this look like? Well, on a graph, an x-intercept, again, takes the form wherever it lies on x, 0, because if you're on the x-axis, the coordinate has a y value of 0. Okay? Pretty consistently, if you lie on the y-axis here, your x value is 0 and your y value in this case is some number, specifically 6. For this one, the x value specifically was 4, 0. Cool. Here's a real simple example. Let's just suppose you had the line, this one, and someone came up to you and said, what are the x and y intercepts? Well, the x-intercepts lie on the x-axis. So looking at where your line hits the x-axis, you can see -3, 0 is the x-intercept right there, and the y-intercept, where does your line intersect the y-axis? And again, that comes at, looks like 0, be careful here, 6. Again, the y value is the one we're interested in. The y is 6. So at the y-axis, the x-intercept is, the x is always 0. The x value is always 0. Consistently, at the x-intercept, the y value is always 0. So real quick, another example. If we were looking at this line, you'd see here your x-intercept is at 4, 0, and your y-intercept, you can go ahead and guess it, down here at 0, -2. Pretty easy stuff. Let's say you were given this equation. You can, if you wanted to, graph this thing and figure out where your graph crosses the x-axis, where it crosses the y-axis. You could do that if you wanted to. Or you can do it algebraically. If you wanted to do it graphically, you'd have to solve for y first, figure out what's happening to y, and then undo it with inverse operations on both sides. You have a -4x and 8 equals 2y divided by 2. And this is quite the process. I'll show you a simpler one. So you'd have to take this, come over here, figure out some points, some x values, some y values. If this is the function, plug in a -2, see what happens, you get 0, and so on. Or you can go back and think, how did we talk about this initially? To discover what an x-intercept would have to be, you're looking at a point that looks like this, where it's some value for x, but you know at an x-intercept, y is 0. So, if you're looking for an x-intercept, go ahead and change y to 0. Because you know, at an x-intercept, the y value is 0, or nothing. So you've got 4x equals 8, and it looks like x is worth 2. X-intercept is 2, 0. What about the y-intercept? Well, for all y-intercepts, they take the form 0 and some value for y. So that means that the x value must be 0 at a y-intercept. Let's take our original equation And instead of x, we'll put in 0. And you can see 2y equals 8. Let's divide by 2 and figure out that y is equal to 4. Well, if that's the case, that means our y-intercept takes the form 0, 4. Huh. Interessante. Let's try another one. Given this equation here, if you wanted to find the x-intercept, guess what you'd have to do? Well, all x-intercepts have the form x, comma 0. That means that the y value at an x-intercept is 0. Take a look at your equation, and if you're after the x-intercept, go ahead and plug in a 0 for y. You can see that 8 times 0 is nothing, and you've got negative 3x equals 24. And to solve for x, divide negative 3 on each side. How about x being equal to negative 8? That means your x-intercept is negative 8, comma 0. What about your y-intercept? All y-intercepts are of the form 0, comma y, because they lie on the y-axis. Let's take a look at the original equation. Be careful here. You've got this idea, but instead of the x, you know that x is worth 0. So coming back over here, you plug in a 0, and this is worth 0. So you have the statement 0 equals 24 plus 8y. But you need numbers on one side, variables on the other. We need to get rid of this positive 24 by bringing a negative 24 on each side. So you have the statement negative 24 is equal to 8y. If you divide 8 on each side, you'll see that negative 3 is worth y. Y is worth negative 3. And you can make the statement 0, comma, negative 3. That's the y-intercept. Hooray! Here's a problem. An equation, 3x plus 4y equals 12. I'm going to show you how you can graph this by using the intercepts. So let's take a look at it. Let's get a graph in here. Okay. To look at these intercepts, you could either go through the process of putting it in this form, function form or slope-intercept form. You have to solve for y. Or what we can do is just figure out the x and y intercepts. And let's play a game called peekaboo. If you were looking for the y-intercept, you know that x must be 0. So this term must go away. So let's play peekaboo. Let's just cover it up because we know x must be 0, and that means y must be 3 to get 12. Okay, let's look again at your original equation, and let's try to find the x-intercept. Well, if we're looking for an x-intercept, that means y must be 0. So let's play peekaboo. Let's cover this one up and say, hooray, I see you, 3x equals 12. X must be 4. So we're looking at an x-intercept of 4 and a y-intercept of 3. These 2 points we know are on the line, and 2 points is all you need to draw a line, connect the dots, and you've got yourself the graph of your line. What? Pretty easy. Much more easy than going through this table business, but we have to know that that's what is happening, that you're representing all the values that could work for this here statement. Good luck with your homework. Bye.